How to avoid over-engineering in software from Uncle Bob, my favorite. Hello, I'm Chris Athanas. I'm a KMP developer. Tech support said they called and they said they really are coming out on Tuesday. They're gonna close that portal up. I'm like, all right, man. I'm doing a reaction to Dev Tools Made Simple. Go give them a like and subscribe. He does all kinds of little clips like this, and I'm on a binge right now of Uncle Bob, and I'm reacting to some of his stuff he says, and like, I think his like head is on the sort of in the right place, but some of the stuff he says is like, what are you talking about, dude? All right, so let's see how he tackles a very complex engineering and management issue about over engineering, and let's see what kind of tips he can give about how to not make your stuff too crazy. All right, let's get started here.
How do you avoid over-abstracting, over-engineering? And the answer to that...
Over abstracting is different than over engineering. Over engineering is different than over... What is he talking? Those aren't two... He's using them as same things? Okay. I mean, I understand kind of what he's talking about, but over engineering is a little different than over abstracting. I mean, you could have like these levels of abstraction, multiple levels of abstraction if you wanted to do that. But I guess if you do more than a couple, you're going to get all kinds of weird other problems that just overcomplicate things. With these big class hierarchies that we tried when we first found out about them. We're like, that's how we solve everything. It's like, no. But like, oh yeah, then DevTools make simple. He always puts these code things. I think it's Kotlin. It looked like it's Kotlin. And he's like, here's some examples. I've got the manager and the all these different minor. Okay, yeah, here we. Man, I should not use the manager, but like, I cover this in my course. Why you should never use manager, based on Yegor Bugayinko's work, based on Alan Kay's work. So yeah, it's on the DLD below. It's a beginner's course. I mean, I go over all the difference between why these are bad ideas, and so does he. And I direct you to go look at his work because he's covered all the bases that I only skim.
That is real simple.
It's real simple to avoid it. Oh wow, because almost every place I've been, this has been a thing where they're implementing features people have never asked for because they think it's fun or whatever. They put it on their resume, or they're adding things on here because they're just kind of getting the space. They're like, I want to use every single feature like they did when design patterns came out. People actually said, I have every single design pattern in this app, so it's a really good one. It's like, no, you're missing the point completely. So that's another thing about over engineering. Let's keep going here.
You only put in the abstractions that you need, that you provably need.
Well, how do you know which one you need, sir? That's the trick, isn't it? How do you? Okay, so does he go into how do you figure out which ones you need? I hope he does, because that's the hard part, is which ones you're gonna need versus which one you don't. And this is all based on debate. I know. Ooh, it's humans deciding on what to do by argumenting and having supporting evidence and demonstrating things. Okay, let's go, Uncle Bob. Let's see what he has to say. Let's go.
So you don't put in abstractions that you anticipate that you might need. You wait until you actually need them, and then you put them in. You will find that you will put a lot of them in just because you're writing tests. The tests will need a lot of abstraction.
Why? Why will the tests need abstraction? Because you want putting they're behind interfaces, and you're doing mock stubs of them. Why, Bob?
So that you can decouple your production code and get inside it and access it from unit tests.
Okay, so interfaces on things, but that's okay. All right.
And then you'll also find from time to time that there are changes that people make, and you'll look at your code and go, man, I didn't protect myself from that. So that's when you do it. Go back and you refactor that.
Didn't protect myself from that. I mean, you just found something you wasn't implemented correctly. You didn't do it right. Your guess was wrong. It was an experiment that didn't go as expected, as all software is. We're gonna need to change it. Okay.
That abstraction in. It's pretty reactive. There's a little bit of
reactive. What does that mean? It means you're going in a cycle a development cycle where you create something, you test it, try it out, modify it, create it, try it out. Man, what this is guy?
Upfront design work at every iteration, some small.
A little big of design work of iteration. Yes, you have to, because you have to imagine what it's going to be doing. And I guess some people, I've heard, just found out some people don't have this ability, but that's what makes us a programmer, because we can imagine what the solution will be, and then we write an implementation of our imagination. And the implementation doesn't necessarily match our imagination, or it will match our imagination, but our imagination does not match the problem space properly. So we need to modify it, change it around. What the fuck? Come on, this
Small bit of anticipatory design, not very much.
Okay, well, how much do we need? Why do we say what's a little much? What's a little and what's too much? I mean, we should know enough to like be able to create something and say, "Oh, does this it?" That's all. That's really most of it is like, does this look like what you want? Does this look good? And then you go, "No, that's stupid. Don't do it like that." It's like, okay, how? Okay, I've made some changes. How about this? And you're like, well, that's better. It's like, well, what about this? Like, okay, what about this? Like, oh, well, that's pretty good. Not all of a sudden the grand entrance. Da da! It's like, no, it goes through this whole cycle. I guess a lot of people aren't familiar with like how that cycle works. They don't want to see it because this is boring as hell behind the scenes. It looks awful. It's very degrading. You're like, wrong, wrong, wrong. It's like, get it better. That's a little better. Oh wow, it's amazing. Then wrong, wrong, wrong. It's like constant.
Little bit of abstraction that you think you're going to need, but not very much.
Okay, what does that mean, sir?
We start to over-engineer when we spend a lot of time designing and not a lot of time implementing.
What's a lot of time? What percent? Could you put a percentage on it, dude? What? 10%, 20%, 90%? And what about if you need to go look into something quite a bit? Some people spend a lot of time researching a problem before they can even think about how they could even implement it in code. People would spend years and years and years on AI. We have no idea. Sometimes we get close, sometimes we get further away. All these things are works in motion. Gosh, how much? He's like, just a little bit. Don't spend a lot of time. Well, maybe we need to spend a lot of time figuring out some of this stuff. Maybe we need to whittle on paper for 6 years before we get a lightning strike and go, oh shit, I can make an operating system by just making a PDP-8 have a scheduling a head drum on a disk. I can build an operating system from there. That's what Ken Thompson said. I have a PDP-8 with a disk schedule, which basically moves the arm on the drum of a disk. He's like, I can build an operating system from this, and that's what he did. That's where Unix came from. I know it's crazy, but you listen to his interviews. He talks about how it all put together. The guy's a genius.
Has anybody had the experience that they spent months designing and then they wrote the code and saw that the code had nothing to do with the design, whatever?
I mean, but that's the process of knowledge work, sir. Uncle Bob, it's a process of knowledge work. You wouldn't writing the code at all if you hadn't thought the stuff through. Come on, man.
Code came out in some completely different form.
Yeah, all the time. This is how humans go through the world. What are you talking about, man? It's a creative process. You think just Beethoven just spits it all out, fully formed. Here it is, completely done. It's like, no, the guy's editing it. He's listening over it. He's playing it back. Come on, man.
But we like to prevent that from happening. So we do that in real short cycles.
I mean, does it have to be short cycles? How about enough cycles so that when you're done, when you get through, when you're ready? Man, this whole 2 week sprint, like all that stuff is just it's leftover from manufacturing, and it needs to go away, and it needs to be knowledge work. It has to be like, I don't know if you need to respect it, but if you respect it this way and you just go for the actual thing we're doing, which is finding a customer, finding a problem that we can solve in the software space that they feel like they want to charge enough for us to make sense that we can dick with this thing instead of doing something else. Like, this is not rocket science, but all right, give me a like and subscribe if you like my rants, and I'll talk to you soon.